Hello everyone and welcome to a new session. In today's session we're going to learn about microscopes, measurements and calculations. We will cover all the different aspects of this topic and all of them are obviously related to A-level biology. Please don't forget to have a look at the revision booklets in the bio below. They will help you with becoming aware of what have been assessed on this topic since 2014 and also will give you a keyword bank that will allow you to have a very focused answers for your exam. Let's start. Okay, so when it comes to light microscope, as I covered in previous videos, you can find them on my channel. In these videos, we showed how light microscope can be used to magnify objects and we can see them in a much clearer way. However, light microscopes can also be used to measure the size of the objects that we are observing under the microscope, and we are doing that using eyepiece graticules. So first of all, what's an eyepiece? Just a reminder that this is the light microscope and these two are called the eyepieces. Okay, so what is an eyepiece graticule? It's actually the glass disc. This glass disc. So it's the glass disc that is placed inside the eyepiece. So these glasses inside the eyepiece are called the eyepiece graticule, and on that glass you can see a scale that is curved on it. So once you look under the light microscope, what you're gonna see is this scale, okay, and that has like 10 millimeter, that is 10 millimeters long. It is divided into 100 subdivisions, and you need to understand that and also it's going to be easier for you for the rest of this session to understand that each mark on this scale or each line on this scale, we will refer to it as a unit as described here. So the graticules gives you a scale in your view, which is the view that you see under the light microscope. However, those graticle units are not real lengths, so you need to calibrate this scale to something else, and that's what we're going to see in the next slide. Okay, so as we just explained, that eyepiece graticule cannot be used directly to measure object sizes, and you need to do calibration first. And also, you need to remember that when you are trying to measure the object size under the microscope, you're going to be using the objective lenses. So just as a reminder, I've covered that in a previous video. You may go and watch it. It will appear up there. But just as a reminder that this is we call the objective lenses, and they come at different magnifications. So we have one here that is 4 times. It means it makes the object that you're looking at here, it makes it bigger 4 times. And then we have the 10 times magnification, we have 40 times magnification, we have then the 100 times magnification. So each objective lens will have different magnifying power, okay, and will magnify the object at different amount. So the graticule or the eyepiece graticule that you are using must be calibrated for a particular objective lens. So once you want to do your calibration, you need to write down, before you start your calibration, you need to write down what objective lens are you using at this moment. And then you start your calibration. Because if you change the magnification, the whole calibration will be changed. So what does calibration mean in here, or in this context? So the calibration means here that you need to find out, for this graticule scale, you need to find out how many one graticule unit is equal in real length. So as we said, the units are referring to each of these small divisions or small lines, okay? So you need to know how many in, for example, micrometers are the 10 units or the 10 lines. So 10 small lines or 10 units, how much do they equal in micrometers? And that's what calibration is. That's what you need to find out. Once you do the calibration, just make sure that you can use the same calibration you have made as long as you are using the same objective lens. So for example, before you started calibration, you put the microscope at 40 times, then you just start your calibration and finding out how many micrometers are, for example, 10 units in the graticule, but you need to make sure that you stay on the 40 times magnifying power. Or objective lens. If you change that, the whole calibration will be changed, and we will explain later on why is that. A practical tip that will help you during your practical maybe assessments. It is very sensible that you record the calibration results for each of these objective lenses, okay, for each of the different magnifications. Just write them on a piece of paper, put them next to the microscope that you are using, and that will save you a lot of time instead of just keep calibrating every single time you want to use the microscope. Okay, so now let's get down to learn how can we calibrate the eyepiece graticle, and that's going to be done using a microscopic slide. It's called a stage micrometer. It looks like that. So what is a stage micrometer? A stage micrometer is, as we said, a microscopic slide that has a curved scale onto it. So this bit of the micrometer, it has a glass disc, okay? And if we have a closer look there, we can see that the glass disc has a scale curved onto it. Usually the scale is 2 millimeters long, okay? It's, as we can see it there. So under the microscope, you will see a scale like that. These numbers above, they are just representing how many divisions we have. So we have 100 division or 100 line on this scale, okay? And each line is 0.01 millimeter, which means if we convert it to micrometers, then each division is 10 micrometers wide. So if this whole scale is 1 millimeter, okay, then this whole scale is actually 1000 micrometer. So that's the first thing that you need to understand. And we will calibrate the graticle that we have just covered against this stage micrometer in order to know how many units of graticle of the graticle are equal in real lengths, and we're going to use this the micrometer, the stage micrometer, to know that. Okay, so how calibration works. So let's have a look now how we can do the calibration in the lab. So the first thing that you need to do is to take the stage micrometer, this one, which has the scale curved onto it, and then you place it onto the stage of the microscope. So this circle, this area here of the microscope, it's called the stage. So what you need to do is, first of all, you take the stage micrometer, you put it on the stage, okay, and then you look under the or through the eyepieces. And as we said at the beginning, you need to be very careful with the magnification that you are using. So let's say that for this example here, we are using the objective lens, which is 40 times. Okay, we're using this specific objective lens. So now that we have prepared everything, we put the stage micrometer on the stage, we put the objective lens at 40 times, and then we look under the microscope. So what can we see? The things or the scales that you will see, first of all, is the eyepiece graticle, which are curved on the glass of the eyepieces, and also you will see the stage micrometer as well, because it's on the glass that curved on the glass of the micrometer that was placed on the stage here. So under the microscope, you will see this view. You will see one scale, which is the stage micrometer, and you see another scale, which is the eyepiece graticle. But as you can see, they are not lined up. So the first thing that you need to do is to line them up. You need to line the scales up. The way you do that is that, first of all, you need to take the left sides of both scales of the eyepiece graticle and the stage micrometer and line them up, as you can see there. So the 0 units of the graticle, line it up with 0 micrometers of the stage micrometer. This will make it easier for you to find out and make the conversion and the calibration. So once you line everything up, you will have a look at, you want to find out how many units of the graticle are equaling in micrometers. So let's have, this is just for random example, okay? That's a random line that I've made. So from 10 units up to 60 units, okay? Let's say that you want to measure this area here. So from 10 units to 60 units, we have how many units inside, or how many small lines inside? We have 50, okay, from 10 to 60. So we have 50 divisions or 50 units inside this area. So now we need to calibrate that with the stage micrometer. which is in micrometers. So that is calibrated onto 250 micrometers. So that area, it is just 250 micrometers. How can we know that this is 250 micrometers? Remember that in stage micrometer, each division is 10 micrometers. So if we have here 25 divisions, so this means that this is 250 micrometers. Okay, so you need to be very pay close attention to the previous slides that we've shown to understand that. So each line on the stage micrometer is 10 micrometers. We have 25 lines here, or 25 divisions. Then this is equaling to 250 micrometers. That's on stage micrometer. What does that, how that is translated into graticules? We can see that 50 graticle units equals 250 micrometers. So now we want to work out then one graticle units, how many micrometers does it equal to? It equals to 5. How did you find that? We just divide this by 50 and divide this side by 50. Then one graticle unit, it's equaling 5 micrometers. On this specific examples, when we are using this specific magnification or objective lens. Okay, remember this number because we're going to use it now in another example. So one graticle unit equals 5 micrometers in this state, or in this specific example. So now, after once we calibrated our scales, as we have just shown, now we go to the next stage, which we want now to see the sizes of actual cells. So the first thing that you're going to do is now to remove the stage micrometer, because now we have done calibration and we already know now that in this example, one unit of one graticle unit equals 5 micrometers. So you take out the stage micrometer, and then now you place your sample. And this sample, usually, it will have a lot of cells. Okay? So what you need to do now is to look under the microscope and see your sample and see the cells. So under the microscope, you're gonna have this view. And on this view, you will have the graticle scale, and you will only see the graticle scale. You're not going to see the stage micrometer scale. Why? Because we have removed it. Remember that the stage micrometer, it has a scale curved onto the glass in this area here, and now we have removed the stage micrometer. So what you have is the graticle scale that is curved on the eyepieces. So under the microscope, you will have a view like that. You will see a lot of cells that are from your sample. So what you will try to do is to align one of the cells with the eyepiece graticle, and then try to measure how many units is the size of this cell. So for example, in this instance here, the size of this cell is from 10 to 40, which means it's 30 graticle units. So for this cell here, it equals 30 graticle units. And from the previous slide, we already know that each line on this graticle equals 5 micrometers. So if we have 30 units, then this means that 30 times 5 micrometers, this is going to equal 150 micrometers. And that's going to be the actual size of the cell. Okay? And that's the whole thing that you need to do. Okay, let's now have another calibration example, and hopefully this will make it even clearer for you. So let's say that in this example, it tells us that 10 units on a stage micrometer scale are equivalent to 40 units on graticle scale. Okay, we need, from this information, we need to be able to calculate the actual size of a cell. How can we do this? I will take you step by step. The first thing that you need to do is to write out the things that we already know. So what we now know that 10 stage micrometer units equals 40 graticle units, and that was already given in the example. The second step that you need to do is to find out then what one stage micrometer unit equals to, because we have here 10 stage micrometer equals 40. So if we divide this by 10 and divide this side by 10, you will find out that one stage micrometer unit equals 4 graticle units. The thing that you always need to remember, that, as we said previously, that stage micrometer on a stage micrometer scale, each unit equals 10 micrometers. You need to remember that, okay? Each unit on a stage micrometer equals 10 micrometers, okay? Why is that important? Because this will help us now solve this problem. So what we're going to do is that replacing this statement here, one stage micrometer unit, with just 10 micrometers, because that's what it equals. 10 micrometers equals 1 unit on stage micrometer. So 10 micrometers then will equals 4 graticle units. The next step to do is to find then how many micrometers does 1 graticle unit equals to. What we're going to do is that we divide this by 4 and we divide this size by 4. Then this will give you that 1 graticle unit equals 2.5 micrometers. So the main information that you need to specify that in this example, 1 graticle unit equals 2.5 micrometers. Okay, so if you use the microscope and then you align the graticle scale with a specific cell, and you find that a specific cell measures 12 graticle units. We already know that each graticle unit equals 2.5 micrometers. So to find the actual size of this cell, all you need to do, just timing 12 by 2.5 micrometers, this will give you 30 micrometers. So the actual size of this cell in this example is going to be 30 micrometers. So now we will learn a different way of calculations that might come up in the exam. So you need to learn how to get the calibration for different objective lenses. Okay, you need to understand that you can calculate the scales for different objectives by using magnification differences. What does that mean? I'll show you now. Like for example, let's say that you have this light microscope, okay, and let's say you are using an objective of 40 times, okay. These are the objective lenses, okay, and you found out that at magnifying power of 40 times, the calibration is 25 micrometers per graticle unit. What does that mean? It just this small sentence, it covers what we have done so far, is that you place the micrometer on the stage, you've done your calibration fully, and you found out that each graticle unit equals 25 micrometer. Okay, that's specifically at 40 times objective. Let's say that now you look under the microscope and you've done the calibration. Let's say now that you want to change the objective lens from 40 to, let's say, 400. Okay, so this means that the magnifying power, it's 10 times greater, okay, than the one that you've used for your calibration. Always remember that this calibration is only true at this magnification. If you are changing the objective lens to a higher magnification, then this calibration will change as well. What's going to happen if you change it to 400 times? This will result in the fact that each graticle unit will now go down by the same factor. So the magnification increased by 10. So the graticle units will be divided by 10 now. So it will go down by the same factor. So now each graticle unit would equal 2.5 micrometers. Because when you increase the magnification, it's like you are zooming in even further. So why did we divide by 10? So the simplest answer is that because when magnification increases, each graticle division or each graticle unit will cover a smaller real distance. So that value per unit goes down. As we said, if the increase in magnification was 10 times, then the same decrease will happen in the graticle units with the same factor. So if the increase is 10, then you divide by 10 for the graticle units, and you get a new calibration now. Maybe to make it clearer, let's have a look at the opposite or a different scenario where we are moving from a higher objective lens to a lower objective. So let's say that you are at 40 objective. So now this calculation or calibration is true. So one graticle unit equals 25 because we are on a 40 objective. Let's say now instead of going up to a 400 objective, we are going down to a 4 times objective. Okay, so this would result in that the graticle units now cover a larger real distance. It's like because we are zooming out. Okay, so the calibration value will go up by the same factor. Okay, so that's what happens. At 4 objective, each graticle unit would be the 25 micrometers, which we already know. This time times 10, not divided by 10. So it's going to be times 10, and this is going to be 250 micrometers. So what does this number mean? It means that at 4 times objective, each graticle unit will be equaling to 250 micrometers. Now let's have a look at a different type of calculations that are required for this topic. And let's say that you might get asked on the exam, it's a very common question that comes up in the exam. You might get asked to calculate linear magnification of a drawing or if of an image that is given on the exam paper. So you need to remember this equation. I've covered it fully on a previous video. Please have a look on my channel, and the video will appear up there. But here, just a reminder that the magnification formula, what it is, it states that magnification equals the image size divided by the actual size. So here's an example. So let's say that on the exam you got this image, and the exam question tells you that the drawn line XY represents 5 micrometers in real cell. Okay, so in real cells, the actual size, which means it's like telling you that the actual size is 5 micrometers. So what you need to know now then is the image size. Okay, how can you work out the image size? In the exam you will use a ruler, and then physically you will measure the size of this line on the exam paper. Okay, so for the sake of this example, let's say if you are using a ruler and then you measure this this line, it gives you like it comes out as 23 millimeters. Okay, once you find out the size of the image, so that's the image size, you need to make sure that the image size is on the same unit as the actual size. So the actual size was given on micrometers, so now you need to change this 23 millimeters to micrometers as well. This means that you times this number by 1,000, and then this give you 23,000 micrometers. So if we plug in all these numbers in the formula, we will find out that magnification will equal 23,000 micrometers, which is our image size, the one that you physically measured, divided by 5 micrometers, the actual size that was given in the exam question. This will allow you to find a magnification, which is going to be magnified, which means that this image is magnified 4,600 times. And remember, in magnifications, there is no units. I think one of the most common traps and mistakes that the students make is that when they are making this division, they forget to convert the units. Always make sure that the units for the image size and the actual size are the same. Otherwise, the whole calculation will be wrong. Sometimes in the exams, they might ask you to rearrange the formula, the magnification formula. Therefore, it's very easy and beneficial for you to remember this magnification triangle, which shows you that the magnification factor, or the magnification, would equal the image size over the real size. That's very easy, an easy way to rearrange the formula. So let's say that in the exam, they told you that the magnification of this image is 4,600. And what they want you to find is the actual size of this organelle here. They named it mitochondrion A. So they want you to find out the actual size of this sample here. So how can you tackle this problem? The first thing that you need to do is to measure the diameter of this organelle using your ruler, like physically measuring the diameter of this organelle. And because, as we can see here, this organelle or this structure is not truly spherical, so you should measure several diameters and then calculate the mean. Okay, so let's say that after measuring several diameters and then calculating the mean, you found out that the diameter of this mitochondrion A is 10 millimeters. All you need to do now is just plugging in these numbers into the equation or the triangle. So the actual size equals the image size, which is 10 millimeters, and always remember that you need to convert it to micrometers. That's the easy, always safe method to do. Convert millimeters to micrometers, and then you will find out that the image size that you have calculated is 10,000 micrometers divided by the magnification, which is given in the question, 4,600. Then this gives you an actual size of this structure or mitochondrion A as 2.1 micrometers. You really need to understand that the reason that we are taking multiple measurements for the diameter is because the structure is not truly or perfectly circular, and therefore if you just take one measurement, it might give you an overestimate or an underestimate value of the actual diameter. So always make sure that you take multiple values. Okay, so the take-home points that you need to remember that eyepiece graticule are etched or curved scales on the eyepiece. They are usually 10 millimeters divided into 100 subdivisions, but must be calibrated. You cannot use it directly. Calibration, use a stage micrometer, which is around 2 millimeter scale. Smallest division is 10 micrometers. Also, you need to remember that you need to align the scales to find the micrometers per graticule units. So you need to do that. Also to find out magnification, which is image over the actual, and to be able to rearrange the equation to find actual size, which is image over the magnification. Remember to have a look at the revision booklets in the bio below. They will help you finding all the keyword bank that is required for this topic, and also they will include all the aspects that were assessed on this topic on the past paper since 2014. Please don't forget to like, subscribe, and comment. If you have any questions about you didn't understand about this session, just write me in the comments and I will answer that. Thank you and see you in a new video.